Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
Well, since we last recorded, I think I've spent over 2/3 of the time in between out in the wilderness, completely disconnected from the world. So what's been happening?
All sorts of fun stuff going on around the shop. Ended up spending a big chunk of that time, actually, when you were gone, building a crate that's going to go and ship off some equipment to a guy in the States that I sold some machines to. So, yeah, building a large crate. That was a large part of that time.
I should have hewn some lumber for you.
You know, lumber is frustrating these days with the astronomical prices of lumber and the really low quality of it. It's crazy. So, yeah, it probably would have been better quality than what I bought from Home Depot.
Although I wouldn't have had time to dry it between now and then.
You know what? That wouldn't have mattered. It would have still been. It probably would have been drier than some of the stuff that I got. That was ridiculous. Yeah, low quality lumber these days is frustrating.
Yeah, I just picked up 12 sheets of spruce plywood, half inch. And it got a little wet on the way home, but it seems good otherwise.
Yeah, plywood's usually not too bad just because of the structure of it. But this was dimensional lumber, and so it was miserable. At least they're 2x6s, so they tend to use better quality wood for that, but it's still not fun. And
nice and warped. You gotta get it all straight for your crate.
Yep. Yeah, exactly. So, yep. So that the crate is pretty bomb-proof and should make it down to the States in one piece.
So you're going to be sad to see this piece of equipment go?
Honestly, it's an engine a straight line engine that I sold, and I haven't actually used it for a while. I did have it set up for doing pens, so that's all it was set up to do for years. I was just doing pens, but I'm not doing enough pens at this point to justify having an engine like that sitting around for set up only to do it. So I will. I'm happy to let it go to somebody else. I do have another more capable engine around that I can use for doing that anyway. So it's not as if I'm losing the capability of engine turning pens.
And I take it you've kept the fixture that you built to be able to turn the pens?
Yeah, absolutely, yeah. Yeah, that was nice that I converted an 8mm watch lathe to a pen chuck for my straight line engine. David Lindo helped me do that years ago, and it has been an incredibly useful device. I can either use a ratchet mechanism on it to have a sort of regulated distance between turns, or it also has a worm drive on it, and I can reliably do sort of 4,800 divisions around a cylinder using the worm drive if I want to. So the combination of them makes it sort of nice to be able to do whatever I want on a piece, and I can reproduce exactly what I did, or I can go back and pick up a cut if I need to, or whatever, just because I've got the flexibility with that thing to do it.
Yes. Very clever, very ingenious the first time I saw that.
Yeah.
I was quite impressed with what you had done there.
And it's also nice because being a lathe the way that it is, I've got access to the 8mm collet, so I've actually just made a bunch of mandrels that use the 8mm collet back end to fit in there. And then I've also got a tailstock, and the tailstock has a 5/16 hole through it, so I can put precision rod through there and make custom holders for the tailstock, so that I can support the back end of the pen or whatever else it is that I'm turning. So it's quite nice. I've actually thought about making a newer one using a slightly larger lathe headstock, probably something off of a tag, mostly so that I can get more center height between the center of the lathe and the bed, and then also be able to extend the length of the bed a little bit so that I can put longer items in there. There have been a few times when I've had requests from people to do engine turning work on things that were just too long to be able to put on that particular setup. So it would be nice to be able to set something up with a little bit more flexibility.
Did you eventually let the fine people of Instagram know that it was not a watch box?
No, I never did, actually. For those who don't know, don't follow me on Instagram, I did post on Instagram that I was going to use that crate as my shipping material, my packaging material for my watches. I think most people figured out that I was joking about it, but I think a few people may have thought that I was actually going to do that.
Yeah, it turned out in my mentions there on Twitter, I missed a back and forth with Dr. Struthers about some chiming watches as well while I was away. So it's too bad I missed out on that. Mm-hmm. And you've been inspired recently by another little project she's been working on with one of her polishing aids.
Well, that was actually something that they built. I think Craig and Rebecca built that years ago. It was one of their first sort of tools for making their own watches. They're working on their 248 project. And this is for polishing screws, polishing the heads of screws, specifically for doing that black polish on the screw faces when you're finished machining them. And it's nice because it uses an 8mm collet to be able to hold the screw in place, and then you can sit there and use whatever level of abrasive is appropriate up to getting it to a black polish. So it's a nice little setup. I've seen a bunch of people doing different things, different setups in lathes. Putting something in the tailstock to be able to put let's say a tin lap in the tailstock, or micro mesh, or whatever you happen to use for getting that black polish, and then you can turn the screw in the lathe while you're working on it. I've seen a couple of different setups like this. Henrik Capella at KHWCC, he teaches making a similar setup to the one that Craig and Rebecca made, and it uses again a collet to be able to do it. Although I like Henrik's a little bit more, just because it has the ability to adjust the height of the feet, so you can get that face perfectly perpendicular to the axis of the screw. Now, it's probably more useful if you're working on a large number of different types of screws, so different thicknesses, different sizes, and things like that. Craig and Rebecca's is probably fine if you're working on screws that all of the sizes of, because they're all the same, the head is all the same thickness. So it's probably fine for that. And in their case, that's what they're doing. So that probably works out okay for them. But I think I'm thinking about making something that's got a little bit more adjustment capability in it.
Yeah, the setup for Craig and Rebecca's is, I would say, more attuned to volume as compared to the KHWCC one. And I would say with both of them, like the KHWCC one more than that, you do have to be very mindful of the fact that you are truly parallel, because you could end up with a screw head that ends up sort of cockeyed and is not perfectly parallel between the top of the screw head and the bottom of the screw head, which was one of the nice things about the lathe style ones, or the Roll-A-Fix I think was a company that made a setup for polishing screw heads back in the day with bell metals and tin and whatnot.
Mm-hmm. Yeah, there's certainly a lot of advantages to the way that Rebecca's is set up, and as you say, being able to make a perfectly parallel face on there, that's a huge part of it. But it does certainly benefit from having something that sort of what those sizes are, or you've got a pretty good idea, or you can even put it in, drop it down so that it's flat on the plate, and then be able to tighten it so that it's right there. Mm-hmm. So there's a couple of advantages of that. If you haven't looked at the photo of it yet, it's got 3 stable feet, probably carbide, and they don't move at all. They're all perfectly parallel, or they're all exactly the same length, so that they stay in the same spot. And that certainly is a nice setup. I think if I were going to do it, I might make it so that the collet could be moved up and down a little bit.
I believe that is how the setup is. From the technical drawing you showed me there quickly, my memory could be off. Yeah, but I think the set screw on the side there was to allow you to raise and lower the collet up and down, and then the collet itself was fixed or pulled tight by a nut on the back of it. There's like a sleeve, and then the collet, and then the nut, and then there's a set screw on the side that you can raise and lower that.
Yeah, so you do get some adjustability from that. I like the idea of being able to do a screw adjustment for height, so that you get controlled height adjustments, and I like that a little bit more. So I might play around with something like that. The other thing that I may do is I may also make a fixture for my Glendo AccuFinish polishing setup. That's what I use for grinding and polishing all of my cutting tools. So if I'm polishing up a graver for hand engraving, or for use in my straight line engine, or even my lathe tools, I use that Glendo AccuFinish for that. And I'm regularly polishing stuff down to 1/4 micron, which is black polish, as far as any of this stuff is concerned. So that kind of a setup, or some kind of a setup that will work with my Glendo AccuFinish, would be nice, because then I get the advantages of having a power hone, something that I can, that I'm not sitting there and constantly rubbing it back and forth by hand. But then, which is one of the advantages of the lathe, you don't have to sit there rubbing it back and forth by hand. But then I also have the ability to very easily change out the different abrasives that are on there, everything from micro mesh to, as I said, to different diamond laps and different ceramic laps as well, which is nice because then I can get different diamond pastes on there and stuff.
Well, maybe that'll be another project for you to repurpose an old 8mm lathe for.
Could be. I think if I'm going to start working with a lathe for that sort of thing, I'd probably just make a tailstock attachment for my Derbyshire and just put laps on the Derbyshire.
Yeah.
The inconvenient thing there is that I've already got a bunch of laps that are really nice for this sort of thing, but they're all 5 or 6 inches in diameter, which would not really be appropriate, even mounted on the tailstock of the Derbyshire to work. They're just too large for it. So I'd have to decide what I'm, sort of what the best course of action is there.
Well, and using abrasives in and around your lathe that you're also attempting to do precision turning on, I would not advise.
By the time you're working on a screw head and black polishing it, you're really only working with very, very fine diamond abrasives. So it's probably not going to be too significant a problem. You're going to be like you're beyond the level of lapping paste, in a lot of cases. So I'm not sure how much of a problem it would be. Also, in a lot of cases, it's electrostatically charged diamond on the plates, so it's not coming off. Like, it's not like a breakaway abrasive, something like a silicon carbide or something like that. So it's probably not a huge issue at that point.
Yeah, as long as you don't end up with a slurry slowly migrating into the headstock there.
Yeah.
Mess up your bearings over time,
Yeah.
even though it's a very fine polishing paste. Anything. Like, the bearings are going to wear regardless.
I think just normal use of those bearings is going to be worse on them than the shorter period of time that I would be potentially polishing on it.
And on your other point there too about the tripods and being careful of how you're moving it back and forth. I certainly hope it is something like a carbide there on the one that the Struthers made. Because if you're not careful, your body's likely going to be moving in a pretty rhythmic manner as you're doing this, and you more than likely will zone out here and there. And I think over time, those feet would be want to wear differently. And that's something you'd want to be careful of there with that, where it's not so much a tripod setup, where it's like the KHWCC one, where your component being polished is one of the feet of the tripod. It's a tripod setup with an additional piece put down. So you've got more of a quadruped there. So it's not going to necessarily stay as level as you like or guarantee that it would stay that level. Same goes for that set screw too. The fact that it's not being pulled in concentrically the way it is with a collet, the way it's fixed, is probably going to give you a slight angle. It's likely not going to be perceptible. I'm positive this setup is perfectly fine for what they're doing. But there's certainly margins of error in there that you should be mindful of as you're doing the polishing work. But I'm interested to see what you end up coming up with. I use a very ancient tripod setup that I inherited from an English watchmaker. A tool I use could very well be 100 years old. I have no idea.
And frankly, something like that would work perfectly fine as well for a lot of what's going on. In my case, I'm going to be producing enough screws that I want to make something that's easy for me to use and easy for me to adjust and easy for me to produce good quality work without needing to think about things like parallelism between the face and the back of the screw, things like that. So it's and also being able to use the abrasives that I'm happy with, that I can get good that I know that I can get good results with. As I said, I've been polishing carbide now for years to an extremely high polish for my engine turning. So it's something I'm used to, and being able to use the same kinds of abrasives for that is just convenient, and I know that they work.
And C&J Duray makes some really nice add-ons for lapping horological items on laps, very much like your AccuFinish.
Yeah.
So looking at what they have for this sort of use case might be beneficial too. I'm certain it won't be cheap, whatever it is they have to offer you, but it'll do a superb job.
Even the laps that Glendo AccuFinish put out are not inexpensive. I think I was looking at replacing a couple of my ceramic laps. I want to say they're asking for a 6-inch lap. I think they're asking $300 US for a 6-inch lap these days. So it's not cheap, regardless of what you're doing with it. I do know a couple of people who've had a lot of success using cast iron laps, and they find that charging cast iron laps with diamond paste is actually really effective as well. I know a lot of people use tin for theirs, so it just depends on what it is that you're looking for and what you're getting out of it.
Yeah. Nickel's another one as well.
Mm-hmm.
Yeah, I thought I had purchased a set of tin laps back in the day, probably 6 or 7 years ago. I bought a set of watchmakers laps, like little bench laps, and no, it turns out they were steel. not nearly as ideal as tin for achieving a really high polish. But
I do have a couple of pounds of tin sitting downstairs that I bought when I was doing some experimentation with Niello and trying to make a version of Niello with tin. So I have enough of it downstairs that I might actually make my own, make a couple of laps for myself for doing stuff. Maybe I'll set up something on the Glendo AccuFinish and I'll actually make a tin lap for it, so I can get that in the mix as well.
Just make a lap of your own. Yeah. There you go.
Got all the tools. Might as well.
It might as well.
Yeah. And in the finishing front, we talked a little bit about finishing last episode on some of what I'm doing with my bridge finishing, and we did talk a little bit about the levels of finishing and sort of where I think I'm at versus where I would eventually like to be. And based on a couple bits of feedback that I got, one of the things that I think maybe was lost in my explanation is that you can't just spend more time finishing something and polishing something and expect to get better results. You can't just sit there and continuously polish the same bevel for 30 hours and expect to get better results than you did after 2 hours of polishing that bevel. It doesn't really work that way. When I talk about the different levels of finish and how you're getting better at it, there are more things that are involved than just sitting there and polishing something. In fact, if you do polish something for that long, you're probably going to over polish it. You're then going to cause problems with the edges being sharp. You're going to have, round over issues. You're going to have, bring in potential other problems with, maybe a bit of abrasive or something coarser than what you're working with to actually get in place. So there is a little bit more to it than just spending raw hours on it. Like when Philippe Dufour talks about spending, talking about a month or two on finishing the bridges in his watches. The reason that he's spending that time is not because he's sitting there for 10 hours just polishing a single bevel, right? There are other decisions that are going into that. There's other things that are happening there that allow him to get to the final level that he's looking at, the way that he's shaping those bevels and things like that. And it's not just about, taking that final polish and just saying, oh, well, hey, this is the finest polish that I have. I'm just going to keep polishing on this for 10 hours and that will get the finish that I want. If that was the case, then, well, all of us could just sit there and polish for that level of time. But there's a lot more that goes into it than just spending raw hours with a stick or whatever it is that you've got your polishing compound on and just rubbing back and forth. It's not quite as simple as that.
And part of the reason, too, that it becomes more time-consuming as you go along is because it requires a lot more focus and intention behind every single action that you're taking. You can't just sit there and quickly move a piece of wood back and forth or a small lap back and forth. You do have to be very careful, very cognizant of what you're doing, what's happening, the feedback that you're going to get audibly from the material as you're working it is also going to say a lot. And I know that some of the top finishers at FP Jaune will actually count strokes once they hit a certain level. If they're trying to get a part to be balanced or very nice and symmetrical between two sides, they will literally sit there and count 10 strokes on this side with this amount of pressure, 10 strokes on this side with this amount of pressure. And it requires that same amount of focus that you need when you're engine turning.
Absolutely.
Like we were talking the other day about how hungry you feel after you've been engine turning. It's because of the amount of calories that your brain is actually drawing from the rest of your body as you're sitting there that intensely focused on one thing for such a long stretch of time.
And once you get to a certain level and you start understanding the metals and the materials that you're working with, you also start to have to deal with things like the grain of the metal and how the grain of the metal can change depending on how it was made. Rubbing the micro mesh paper in one direction on this piece of metal doesn't react the same way as it does on that other piece of metal. And the reason why is because the grain structure is slightly different. And now you have to be able to recognize that. You have to be able to see that at the magnification that you're working at. The longer you're working at that high level of magnification, the more effort it is for your brain visually and just cognitive processing, as you say, to work with. And so you can't work at high magnification for super long periods of time like that. But that's what you need to be able to see things like how the grain structure of the metal is affecting the polish that you're getting on the piece, and what's a red herring in terms of where there's a problem with it, where there isn't a problem with it. Rich and I were talking a little bit about this a few weeks ago, talking about metal finishing, and there are a lot of common mistakes that beginners make when it comes to metal finishing. Like, one of the first things that most people do is that they don't start off at a coarse enough level of finish when they're doing the initial shaping. And so they spend too long trying to shape a part using too fine of a tool. And they then waste a lot of their time doing that. If you use the correct level of abrasive to begin with, you can very quickly move from the basic shaping and then move on to removing the scratches from that and continuing to go into the finer and finer abrasives. A lot of beginners just don't do that. They don't start coarse enough. And then the other problem that they run into is that they think that they can go back, or they can remove the scratches from, let's say, the sandpaper 2 previous levels before with the finer sandpaper, and that if they just keep going at it long enough, that they'll remove the deeper scratches, which they should have removed on the previous version, the previous level of abrasive. But the problem you run into there is that often you can't. Often what you're doing is you're just going to round over the deeper scratches with the finer abrasive. What you need to do is go back a level, take out those scratches properly, and then proceed forward. A lot of people, especially a lot of beginners, just don't want to go backwards. They think that if they go backwards, they're going to have problems, or they're just wasting their time. But what they don't realize is they're actually going to get a better finish by moving back a step, taking out that scratch. So in my case, I'm going from a 10 cut file to a 10 micron micro abrasive. And then I'm going to, I think it's a 3 micron, a 1 micron, and then a 0.3 micron in those micro mesh papers. If I'm sitting there on the 1 micron micro mesh and I'm seeing scratches that were left there by the 10 micron micro mesh, I'm not going to try and take them out with the 1 micron. I'm actually going to go back to the 3, take them out properly with the 3, and then go back to the 1. Because otherwise I could be spending far too much time trying to remove those 10 micron scratches using a 1 micron paper. And also that I may just never get them out. I may end up with all these little rounded over scratches, and that's hugely problematic. So there's a lot of little things like that you start to learn as you get more and more experience with this. So things that will just make the overall level of finish better, things that will speed up your process as well. And this is why, just sitting there for hours on end is not necessarily the way to go.
And one way to help identify whether you've gotten all the scratches out earlier on, this doesn't work as well when you get finer and finer, because you do have to respect the grain of the material, is to actually change the direction in which you're passing over it. So once you see that all of the lines you're leaving behind are all going in one direction, then you know that all of the lines that were going in the opposite direction or slightly offset from that with the previous mesh that you were working with, that you know that they're all gone. Mm-hmm. And then you move on to the next one and then change your orientation again and work that.
Oftentimes at the end of a level of abrasive, I will actually take the last few passes perpendicular to how I've been polishing up until then. Because at that point, you're going to then see, okay, are there any of the previous level of abrasive scratches still left in it? And then also when you start working on the next level, you're immediately working perpendicular to the last couple of passes that you did with the coarser abrasive. And so it becomes much easier to identify when you've removed those previous abrasive scratches. So there's little tricks like that. Unfortunately, with some things, especially something as small as the bevels that you're using, en gouage, it's tough to
hard, yeah.
It's tough to do that, especially because if you're moving, let's say, if you're moving perpendicular to the axis of the bevel, it becomes very easy to change the angle that bevel is at all of a sudden. Whereas if you're moving along that bevel, it's much easier to maintain that exact angle that you're working on. And that sort of thing can be problematic if you're not careful, especially when you're working on the more abrasive stuff. Like I wouldn't really do that with a file, for instance. I tend to prefer working with a file so that I'm moving sort of parallel to the length of that bevel. And that way, even though it leaves, deep scratches in that direction, at least I know that I'm creating and maintaining that particular edge and angle exactly how I want it. And then when I start dealing with the micro abrasives, then I'm willing to go sort of perpendicular to the length of that bezel.
And if you focus too long on a single area, say trying to get out a deep scratch, you can end up with a wavy effect. And
Absolutely.
That can absolutely ruin
Absolutely.
a piece. Yeah, it is certainly an art.
Yeah.
Getting a really fine finish on things. And as well, if you're trying to keep really flat surfaces, like the type of finish you'd see with a lap, you're generally better off with a lap. That's why a lot of the anglage that you see in watch movements is rounded and not this really rigid 45-degree angle, unless it was done with like a diamond cut chamfer, like a diamond tool to create that diamond cut chamfer. Because to achieve that otherwise by hand, you're bound to end up rounding it in some way, just in the motion of your body. Yeah.
Yeah, that's one of the things I'm fighting with. I am actually putting flat surfaces on there. I'm not putting a round curve on those bevels. And it certainly does take more work to do that. And it is, you don't have as many places to hide when you're working on a flat surface like that. And then a few other things that, for those of you who are interested in getting into doing fine finishing on things, a few other things to keep in mind. One, change out your abrasive faster. Most people tend to continue using a file or a piece of sandpaper or whatever far too long. It's loaded up with material from what you're removing, and or it's lost its abrasive. A lot of abrasive material is designed to wear away. That's part of how it's working as you're abrading the material, and so you're losing that thing that you're trying to get. Now, in the case of files, for instance, when I'm working with my jeweler's files at the bench, what I do is I tend to migrate the files to finer and finer finishes. So something that started out as a coarse file, after I've used it for a while, will end up getting moved down the bench to more of a fine file. And then I buy a new file that's coarse. And I sort of slowly work its way down to the point where it's not really useful, and then it gets turned into a knife or something like that. But with things like sandpaper, the average person who uses sandpaper for, let's say, finishing some wood occasionally, or maybe sanding some paint that they've been working on, they would be shocked at how quickly I discard sandpaper. It is a consumable that I go through very quickly, even with the micro abrasives, where you're not really building up a lot of material on it, or you're not removing a lot of the micro abrasive that's on it. I get rid of those very, very fast, and I'm constantly switching them out. And then the other thing that people don't do is they don't clean their work in between moving from one abrasive to another.
It's absolutely vital.
And especially at this level, if there is even the smallest bit of abrasive or a particle from the piece that is left on the work, and you go to the next level of abrasive, you have basically invalidated that finer level of abrasive. You need to clean the work before you go any further. In some cases, that means, doing a proper full clean on it. And like when I'm doing the work with, particularly once I go into the polishing compounds, once I move into polishing compounds, because I'm using two different layers in this case, I actually do a full clean on the part from one polishing compound to the next. Because if I don't remove the Luxor polishing compound before I start working with the rouge, I'm wasting my time. The rouge is never going to do what it needs to do just because there is still some of that Luxor polishing compound there.
Coincidentally, in the vein of metal having a grain structure, the most recent issue of Europe-Star magazine had a number of interviews with different independent watchmakers, and one of those watchmakers was Denis Flageolet from De Bethune, and one of the key quotes from him that stuck out to me when I was reading his profile was that he's discovered in time that you work metal like wood because metal is fibers, is the way that he framed that. So he certainly agrees with that grain structure. And I would say that most physics professors or physics professionals would also agree with you about the grain structure inherent within metals.
Most people are familiar with the grain in wood and it's obvious to them. But once you start getting to a certain level with metals and you start working on metals at certain levels of precision in particular, you start dealing with the grain structure of metals. You also start dealing with internal stresses in metals and things like that. So these are all things that you have to take into account when it comes to working with metals. And once you want to move past a certain level, you absolutely need to make sure that you take all of those things into account. And it's one of the reasons why people become picky about where they get their metals. Mm-hmm. You don't just buy whatever scrap you find at the local metal dealer and from the back corner or whatever. I'm willing to pay a premium for certain materials, and that's because I know exactly how it was made. I know exactly what they went through to do it. I know that it's been normalized. I know that when I cut into it, it isn't going to turn into a Pringle chip on me. All those things, right? And those are things that you can't guarantee if you're just buying whatever mystery metal you find at the local scrapyard.
And one example in the world of horology of this being taken to the nth extreme would be Rolex with their 904L steel, because they were finding when they were applying the finish to their cases and their bracelets that in some of the batches they were getting from their supplier, there'd be some micro tearing happening, and it turned out that the supplier wasn't using the forge that they were creating this alloy in exclusively for the 904L steel. They had also done some titanium forging in there, and small atomic bits of titanium residue ended up in the batch of 904L, and it was messing with that final specular finish. So much so that Rolex now has a foundry that it owns and operates that exclusively creates the 904L steel for them, which they now refer to as oyster steel. And the same goes with all of their gold alloys as well, things like their Everose gold. All of that metallurgy is done in-house at their very own foundries in Switzerland.
If you're on Instagram and you're looking to follow some people who are doing high-level finishing work in the watch industry, there's a few people that I highly recommend following. Philippe Narbel, he's doing some great work on Instagram showing the process of finishing, talking about his process and the tools that he's using, the materials he's using, things like that. And his company, Manufacturer SA, I think is the Instagram handle. We'll put links to these in the show notes. Again, they're showing off some great work that they're doing there. And then the other person is Natalie Jean-Louis. Again, she's an experienced watch finisher in the industry, and she's showing some amazing work and is sharing some amazing details about the kind of work she does. So make sure if you're interested in doing and seeing what people are doing at a high level of watch finishing, some excellent people to follow there. There's 3 accounts there that we'll link to. Absolutely worth following.
Trying to convince me to get on Instagram, aren't you?
John, I'm going to get you on Instagram eventually. By hook or by crook, I'll get you on Instagram.
Yeah, maybe one of these days I'll hop on the Instagrams.
Oh yeah.
That's, yeah, not quite there yet. Although this is tempting. I would say I'm going to go and check these guys out, but I know that I'll get walled by Instagram if I do. Yeah. I'll have to find some random link somewhere that links to one of their posts, and then that's all I'll see of them. But in the vein of social media and things being posted, last episode we said we had at least had some prior art on Konstantin Chaikin with his Project Minotaur. It turns out his earliest post with a photo of his Minotaur watch was on February 12th, which is prior to the date that we did publish that episode with the cover art. However, there are numerous counts well before February the 12th, 2021, when we did discuss Project Minotaur in public. So we still have that. Our dial design, which was unique to us. We unfortunately wouldn't win the prior art on that one in a court of law. Oh well, but I doubt it will ever come to a head with Constantine.
I don't think we're going to be competing with him with our one-off watch.
Exactly.
Now, actually, going back a little bit to the finishing stuff, because this is a little trick that you and I spoke about, and you had never heard of this, and I think it's worthwhile sharing because it's something that's actually super useful in a bunch of different contexts and not just what I'm doing. I don't know where the first time was that I ran into this. The earliest posts I can remember about this are probably from John Saunders at NYC CNC. We've spoken a few times in the past about John. He's been running a great YouTube channel for years. If you want to learn machining and you want to learn CNC machining, it's an excellent place to get started with it. And one of the things that they focus on a lot, because frankly, this is a huge part of the job, is work holding. And how do you safely hold a piece of metal to then machine it in a mill or in a lathe? And this little trick that he started showing has begun showing up everywhere, everywhere from luthiers to jewelers to machinists. And I've been using it in a number of places now for years, and it is exceptionally helpful. And it involves using super glue and tape. And the way that they've been using it is they're trying to hold a part where they need to be able to get to 5 of the 6 sides of the part, and they don't want to hold it in a clamp, or they don't want to hold it in a vise. And so what they do is that they hold a flat sheet of aluminum in the vise, and they put down some painter's tape, and just blue painter's tape that you can pick up at any big box DIY reno store. And then they put another layer of the tape on the underside of the part that they want to hold. They put a little bit of super glue onto the tape, and then they stick the two parts together and they clamp them together for a few minutes until the glue sets. And at that point, you've created a very stable, very solid hold on the workpiece. And it can handle a surprising amount of load against it. It has a lot of lateral stability and a lot of lateral hold. It doesn't hold up well if you pry it off. It pops off very easily when you pry it off. But in terms of side loads on the part, it actually holds remarkably well. And this is super, super useful for very thin parts. So whether you're working on a thin sheet of metal that you want to be able to grab and you don't want to deform it, because one of the problems when you're holding something in a vise is that you can very easily deform the part that you're working on. So this is a great way to be able to hold it in place and be able to actually, keep it flat and keep it stable. I know that in the watch industry, there are a lot of watch manufacturers that use things like super glue to hold dials onto chucks while they're working on them, whether they're doing engraving work or whether they're doing engine turning and things like that. Or they'll put it onto a plate that they then hold the plate in a chuck. So there's a lot of that kind of thing going on. But the advantage of this is that it's very, very easy to then pop the part off of the work holding surface afterwards. So I've actually been using this recently to hold down the bridges that I'm bead blasting with the ruby material that I'm blasting with. So I'll actually hold the parts down there. And the advantage of this for me is that it gives me a good solid work holding surface. But then I don't have to spend hours, dissolving super glue off of the part or whatever to get rid of all of that. And, you typically do that in acetone. In this case, it's very easy to just peel the painter's tape off of the back of the part, and it doesn't leave any residue behind. Very, very simple to work with. The tape that I tend to use on the dials is a masking tape for the powder coating industry. And the convenience of that, it's a plastic tape and it's a more consistent thickness. I get better, better consistency there. And therefore it keeps the dial more level. I'm I'm not worried so much about there being deformation in it. And I'm talking about very, very small amounts, like less than 1,000th of an inch, but that's still enough to show up in my engine turning. So the advantage of this masking tape for the powder coating is that you do get a more consistent surface. It's flatter and it's nicer to work with. So I'm really, really happy with the results that I get off of this. Again, holds down more than fine when it comes to the forces that I'm putting on it when I'm engraving, when I'm using it on the straight line engine or whatever. And I'm super, super pleased with it. And then what I can do is I can build a standardized plate that I can put these dials onto, and that I can hold in place on the, on my lathe, on my engine, whatever it is that I'm trying to do. I don't have to worry about having a lot of excess dial material around it to hold on to, because that's a big problem. I've seen people use rings that hold down the outside edge of the dial material. But the problem there is that you need to have waste material that you then cut away, which, okay, if you're working on an inexpensive dial material like brass or whatever, that's not a big deal. Silver, not a big deal. Palladium 500, it starts to get expensive. Gold, platinums, it starts to get really pricey to have a lot of waste material there. So this is a really good way of being able to get that stable surface, that nice hold that you want, without needing a lot of excess dial material there to hold on to.
Yeah, I haven't had a chance to try this myself yet. I didn't drag a mill with me out into the Canadian wilderness. But I am curious to try this next time I have to, say, make a setting lever or a flat part like that from a watch. I can see it be useful for, chronograph hammers and things like that as well. I have had to make the odd one for vintage pieces for which components are no longer available. And this would be a fantastic way to work gold. The only time I've ever had to use an eyewash station was I got interrupted while I was heating up a part to release a cyanoacrylate bond. Just to get the two pieces apart quickly, because it works a little faster than using acetone.
Yes, it does.
But you do have to be mindful of turning the heat off at just the right moment. I thought I would be quick enough with this quick request someone had made, but of course I got interrupted within an interruption. And by the time I walked back into the room, just opening the door was enough for the gas that had been let off. That I flicked off, closed my eyes, flicked off the switch, and headed for the closest eyewash station as quickly as I could. That was just completely noxious. So I like the fact that this is easier to lift the part right up off of. You don't have to worry about dissolving the cyanoacrylate or heating it to break the bond. It just pops right off. I would be somewhat concerned about thinner parts. I don't know how thin of a part have you been able to pop off without warping?
0.1 millimeter.
For real?
Yeah.
What were you doing at 0.1 mil?
Yeah, you get some thin sheet that you're working on, some thin foils and stuff like that, and you can get some pretty thin stuff in there, and it'll pop off easily enough. One of the problems with just using CA glue straight on a part, yes, you can release it through heat, but the problem is that the heat may change the part in a way that you don't want to have happen.
Yeah, that's
a problem especially when you're dealing with a dial where you've just spent all this time putting beautiful, bright, polished engraving on it, and then you heat the part up, and that heat is enough to change the polish level on a part. So heat is not really something that you want to bring into play. Depending on what you've done with the dial, you don't necessarily want to do that. You can also end up with deformation in the metal because of the heat, especially if it doesn't heat evenly. You can get some deformation, or you can affect the temper of a part if you're working with steel and you're already working on something that's been hardened. So this is a great thing to do if you're black polishing a piece of steel that's already been hardened. You don't have to worry about that. And then also you end up with problems with acetone. So for instance, if you leave a piece of brass in acetone too long, it starts to affect the brass, and you start getting a lot of discoloration with the brass. So this is sort of a nice balance in between. It gets you in and out quickly. You don't have to worry about using a wax chuck, which is the traditional way of doing this sort of thing. That can be a bit of a pain to do.
And boil it off in mineral spirits.
Yeah, exactly. So this just has so many advantages. It has speed going for it. It has reasonable work holding. You get some pretty strong work holding out of it, and you get really nice flat, even, work holding surfaces, which is great. And you, as I said, you can hold some really, really thin parts on here if you want to, and it works out really well.
Yeah, the hot plate I was using was a Simeric hot plate from Thermo Fisher Scientific. So
Sure.
Like, it's another reason I was okay leaving it for the very short, what I thought was going to be a short interruption. So you can set the temperature. And it's usually very good about holding it at that temperature. So I wasn't at all concerned about messing up the temper because I was well below what that steel component had been tempered at.
Sure.
But yeah, I was completely caught off guard when I opened that door. I am excited to give this a try sometime.
Yeah, and do you see these days? There's a lot of luthiers who are using this, especially when they're working on veneers. They're let's say they're doing a fingerboard for a guitar or something like that, and they're doing an inlay into it. This is a really convenient way of holding the fingerboard down to the bench while they're working on it, or if they're doing some kind of a heavy level veneer that they're putting on the top of the guitar, and they need to do some carving in it or whatever. This is a great way, again, of being able to just hold it down. Be able to, they can just put it straight on their bench if they want to. So you can hold down a thin piece of wood, which otherwise you really don't have a good way of holding, and then be able to use a hand plane on it or gouges or whatever to shape the piece of wood and carve it. So it's being used all over the place. It is a really powerful technique, and it's not appropriate all the time. You can still quickly get to the limits of its work holding when it comes to, let's say, machining a piece of steel or brass or aluminum or something like that. If you're trying to make a 3/4 inch deep cut out of a piece of aluminum, this is not the way to hold it, right? You need to be gentle. There are limitations on it. But one of the nice things with the videos that John has produced on this is that they've actually tested some of that, and they've said, okay, here is a 2 by 3 inch block of aluminum. How hard can we push this before it releases? And they push it really hard. So it is quite remarkable. If you've got enough surface area, then you can do that. I've also seen people use vacuum chuck. I know the Breguet uses vacuum chucks on some of their engine turning equipment. And again, if you don't have that vacuum chuck built exactly right, and of course they're using the same dials over and over again, so there's some advantages there. But if you don't have that vacuum chuck built exactly right, then you can also end up with deformation in the metal from the vacuum chuck. And trying to make a vacuum chuck that spins is a pain. So there's a lot of disadvantages to that sort of thing as well. So this just has a lot of conveniences when it comes to how you can work hold, and it's certainly worth trying if you're trying to hold something small that's delicate. It's something to give it a try.
I remain curious as to how you got that 0.1 mil piece off without deforming it. It must have been a very, very thin razor blade. Delicate touch. What'd you do? What's the secret there?
I can't give you all my secrets, John.
Come on. Well, I do appreciate you sharing this one with me. It is a game changer, really, for work holding. Yeah. Especially on small flat components, like a lot of the stuff that I end up having to recreate.
And that's just it. A lot of jewelers, a lot of watchmakers, even machinists, woodworkers. There are a lot of people that are listening to this and are struggling with that kind of work holding. And this is one of those tricks that it will shock you the first time you use it, and it will just work. And it really is remarkable. So we'll put a link to the powder coating masking tape that I use. I get it from McMaster Carr. I'm sure you can get it from other places, but McMaster Carr is convenient to get it from. And you can get it in different widths. So I have some in 2-inch widths and 4-inch widths, depending on the size of piece that I'm working on. And it's really nice stuff to use. So we'll make sure to put links to that. And if you don't need that level of consistency in the base layers that are holding this, then you can also just use regular painter's tape that you pick up at your local big box store, and it worked really well.
And if you, dear listener, happen to use this technique yourself, we'd love to hear about it. Feel free to drop us a note at hello@offhours.show, or reach out to us on the social media platform of your choice.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. John can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.